I'm going to time myself and see how long it takes me. This thing has been sitting here for days, and I've wiped it off, and it just continues to drip. See that? So it's below the level of the hydraulic tank, so the oil is just slowly making its way out. There, see that drip? So, even though I'm not really wanting to do this right now, I'm going to get to these hoses and plug these lines. That can sit like that until I'm ready to get to work on it. Hey there, welcome back to Farmcraft. I'm John. This is my Cat D3 dozer, and of course it needs more work. This thing always needs more work. Today I'm working on hydraulics, and I've already done some hydraulic work on this, but I've got a few new tools and a couple tricks up my sleeve that I hope is going to make this go a little quicker. Let me show you what we're going to be doing. So, previously I rebuilt this cylinder, but it is still leaking around the gland, and there were a couple of nicks on this rod. I didn't think it was anything significant, but either I got a bad seal or the rod nicks were enough. I think what I'm going to do this time is just take it apart again, put a new rod on it, and put a new gland seal in it. I'll be interested to open that up though and see why that one's leaking. This cylinder right here actually has part of the chrome missing on the rod. It's actually not leaking, but I'm gonna rebuild that anyway because I'm here and doing it. And then finally this one. This one was nice enough to wait until I was done with the pond job, and then it started leaking like crazy and left this big patch that I now have covered in sawdust of oil on the concrete. This is the cylinder that I put a new rod on, and it looks great. That's how I would wish the other side looked. That's what it should look like. So that one's good. These two and the one around the corner are getting rebuilt. This one here is for rotating the blade, and it's not leaking, and it's very easy to get to, so I'm going to leave it alone. All right, I'm going to start with the worst one first. So while it's still on there, I'm going to go ahead and get the gland nut loose. So I need some Allen wrenches and my chain wrench. This is a chain wrench made by Vevor, and Vevor is the sponsor of this video. I have used and abused this chain wrench in the past, and I'm going to abuse it again in this video. And this tough thing just puts up with it. You really shouldn't put a leverage extension on a wrench like this and expect it to survive. And that's especially true with one that only costs $36. Of course it's not going to be easy. Never is. That's the old persuader here. Man. Gonna have to heat, because you don't want to be heating and not give it anywhere to expand to. Goodness gracious. I mean, that's at least a 5-foot lever arm, and I'm putting most of my body weight on it. Vevor makes some pretty tough tools. Man. I mean, this thing's loose. I'll take it all the way out just in case. Now that's a 6-foot lever arm. Man, I gotta be putting 600 foot-pounds on that. Guess I'll heat some more. We're gonna be using a couple other well-built tools by Vevor later in the video. Specifically a really cool budget-friendly solution for a welding positioner, something that comes in really handy in this repair later on. Grief. Alright, I am sitting on that Hell yeah. But while that one's over there cooling off, I'm going to go ahead and start on this one. I'm hoping I'll be able to get this one apart without having to heat everything, because then I won't ruin the seals in there. Like I won't ruin the wiper. Should I do the vacuum trick? So I've got my vacuum cleaner going into the hydraulic tank, making a negative pressure there. So in theory, these things won't leak now. Well, not perfect, but a whole lot better than it would have been, that's for sure. Come on. Got that one. All right, and this will be the third and last one. All right, all three gland nuts are loose. That's a big hurdle out of the way. So I need to take this all the way off because the blade's in the way, and taking the whole blade off obviously would require taking this off anyway. So I got to get that one. That one's going to be kind of tough, and then hopefully that pin won't be too hard to get out of there. Uh-oh, just jinxed myself. So that's first, and then I'll get that second, and then we should be able to pull it out of there. Look at that. Well, that was a little easier than a track pin. And now it's this pin, and we'll be off. And let's see if I can get this thing off here without getting a hernia. So just noticing something here. This width here is significantly wider than the width of the cylinder, and someone has put this in here to just act as a spacer. The bushing is actually not worn out. The pin and the bushing, there's not a lot of play there. And you know, that's one of those rotational, so it's fine. I don't really have a problem with what they did. That's just in there to keep the cylinder from, you know, rattling up and down. I'll show you the other side. See, there's a similar piece underneath that, because this is not nearly as wide as this, which tells me this is not the original blade on this thing, which doesn't surprise me. This thing's almost 50 years old. was waiting for oil to come shooting out of that thing. Yeah, I caught a lot of it. Yeah, I think you can see the barrel looks really good. Always hard to focus on that. Let's see if this is going to play nice. So this is the wear band. The purpose of the wear band is to take the pressure off of the seal and obviously protect the actual piston from contacting the barrel. So when the cylinder is laying on its side and this is putting weight against the barrel, the piston's just laying there, the wear band is what's going to take the load. So this stuff just is tough and can stand up to that. Whereas the seal needs to be flexible so that it'll seal the oil and it would compress over time. Important for cylinders that are oriented sideways. Now, one thing about these is they often get replaced when they don't necessarily need to. I mean, I can still see the writing on this. So I'm going to put a caliper on here where I can see the writing, and we measure 133 thousandths. Same, 132. So yeah, I mean this wear band is basically new, so I'm not going to bother replacing it. So here's the seal. And I remember this from the last cylinder I did on this machine. It just splits. It's a crazy seal. And then that O-ring behind it gives it some preload. And that is it for the piston. Alright, so here's the gland, and obviously the wiper is destroyed. But if you look down in there, that's the seal, and there's a chunk out of it right there. It's like, yeah, the whole thing's just disintegrating. See pieces coming off of it. So that is why that one was leaking. And this is the seal that usually goes. This is just the seal that takes the most abuse on any hydraulic cylinder because the rod's going in and out. The rod gets dirt on it, it pushes in. If the wiper doesn't take the dirt off, it hits the seal and wears it out. I think that's a little buffer, and what that is it kind of takes shock load off of the main seal. So when the oil pressure builds suddenly, this will cut it down and kind of smooth it out a little bit so that this doesn't get nailed. Well, doesn't that look backwards? That's an O-ring. But the pressure is that coming from this way, and this looks like a backup ring to me. It has a concave side, a flat side, and the O-ring fits right in the concave side, and it was like that with the O-ring away from the pressure. Don't know. Don't know. This out, I'm going to try to use this puller and a slide hammer. And it's probably going to take a few attempts. Be my guess. Slide hammer. Alright, let's put this sucker in a vise. Boy, things do not want to stay out. to wedge them out. There you go. All right. So this is induction hardened chrome rod that I got from CRC. They're not a sponsor, paid for it with my own money, but they're a good supplier, and after shipping and everything, these are $80 a piece. 1.5 inch chromed rod, cut to the length that you need, induction hardened, 80 bucks. Seems pretty reasonable to me. Alright, let's get the second one off of here. It'd be nice if I could get that gland to go ahead and pop out. I can catch the oil right now. Save me some work with the come along. So let me go get a chisel and see if I can pry that thing out of there. That hurt. I was pulling back and the gland acted like a slide hammer and got me right there. I don't recommend slide hammering your finger. That wear band's got some wear on it. And that worries me. What am I going to see in the barrel? So I can tell you the bulk of the barrel looks good, but there is a spot right here where it looks like a piece of metal or something got jammed against the wall and raised up a little burr on this output hole, and that's the same width as the spot I'm seeing on the wear band. So that's what did it, but I don't see anything else in here, so I almost think that was there the last time this was rebuilt. The cylinder doesn't go all the way up to that, and the majority of the time this cylinder is like midpoint. I don't think I have a major issue here. I'll have some bypass leakage when it's fully extended, which will be almost never. Not really sure what did that, but I don't see a need to put a whole new barrel on it just for that. I want to spend some time smoothing that, especially right in here, because when I push the piston in, it is going to go over that area, even though once it's assembled it doesn't move there. Yeah, no sharp edge left there, and wow, you can see all the metal chips from sanding that. I'm gonna have to clean the heck out of this thing. Alright, first thing I'm gonna do is wash this thing out with brake cleaner.
"2,000 years later."
Alright, let's get this torn down. Amazes me that that one wasn't leaking. Well, that one's not going to play nice. hard to beat the actual foot-pounds. There you can see that scar on the wear band. It's just right there. I mean, I think the wear band would still be okay to use, but if they can get me a new one, I will. Sometimes the hydraulic shops don't have these in the right size. That's the easiest piston seal in the world to install and uninstall. And I mean, it looks perfect, so just pulled out the gland seal and the buffer. Those look fine. Let's get the wiper out. And I found something interesting when I removed the outer gland seals, but my cameraman's an idiot. This one has the O-ring facing the pressure. The other one was the opposite, and I think it was wrong. But given where it's installed, in a place that doesn't move, I don't think it mattered. It should have been the other way. I could go to CAT and just buy the cylinder kit. But when I did this the last time, the cylinder kit cost like $125. And I was able to get 2 cylinders for like $80. Significantly cheaper going to my hydraulic shop. Alright, last cylinder. But this one I don't have to take the barrel off. I'm just going to take the rod off and obviously the gland and everything. So I am going to protect the rod on this one because I'm not 100% sure that it needs to be replaced. But I'm going to try to figure out why this thing didn't get fixed the first time. Gonna have to come along that. Or I could look at maybe putting some compressed air in there, which would force the piston this way. The problem is sometimes you launch that thing and I don't want to do that. I'm hoping that piston seal will be fine and I'll be able to reuse it. Squirting oil all over the place. And that's why you don't use compressed air to get it out. For the record, I didn't even have my air on. I put a little bit of air in the hose. The only thing that was propelling that was the spring in this, because I didn't want the PSI to get too high. And it still did that. Idiot. Alright, well hopefully I didn't tear anything up as far as the seals. If I did, I'll just buy new ones. And as I recall from last time, this barrel looks perfect. I think a GoPro films a barrel better than my Canon does. That oil went all over the place. I call that rust proofing. Let's see if this one's going to need some foot-pounds. Yeah, so this one I'm not doing anything to the cylinder, the piston I mean. Yeah, everything there looks good. So I looked down in here at this gland seal, and that is a good looking seal. Yeah, I don't see anything wrong with it. And I think I know what's happening. That seal is probably at most 1/2 inch dimension in and out. If there is a scrape on the rod that is longer than that, like these right here, that's going to let oil get down behind and then come out
right past that seal, and then of course the wiper doesn't hold any pressure. It's just going to go past the wiper. And that's all it is. It's just this one area right here. But that's the primary use area of this cylinder, is right here. So that actually fits. It wasn't leaking bad, but it was leaking. And I don't want it leaking. Could you fill it with JB Weld? People tell me yes, you can. And maybe that would work. But I'm here. I've got the tools. I'm going to put a new rod on it. This is on the cylinder that was leaking so badly. And it's got some pretty deep nicks off of the chrome. There, a couple more here. And then the real winner is that one. And that's the one that wasn't leaking. Isn't that funny? How was it not leaking? I think I ordered those a little longer than I needed them, but shipping was a lot of it, so that doesn't really matter. 23.5 inches. This has a center drilled in it, so that's very helpful. So the first thing I'm going to do is turn down this weld area and get the old rod off, and I'm going to leave a short piece that is about 5/8 so that I can just drill a hole in the rod and then line the two up, and it'll be perfectly centered. You'll see, it's basically using the precision of the lathe to keep me from getting anything off center. This is one of the new tools I got. That's a ceramic insert. Should be able to cut this hardened steel layer on the outside of these rods. Ceramic, they don't need coolant, and you want a very high RPM. And the fastest my lathe will go is 1400 RPM, which actually is a little slow for what ceramic would want in surface feet per minute for you lathe users out there. But we're going to give it a try, and we'll see what it does. Let me make sure I'm not going to hit the edge there. Close, but no. And yes, I have eye protection on for this. In fact, I've got face protection on. This thing's whipping. So far, all I can say is wow. Having tried to cut that stuff before, even with good quality carbide, whew, yeah, that's awesome. Yeah, that file's digging in. You can see the file won't even begin to dig into that. It digs into that just fine. So I'm through it. That was really hard for me to do last time. That was a breeze. My other new tool is this button insert. Gives you a nice radius, great for turning down the weld and basically giving you the plug that you need to put that eye back on the new rod. Hit a hard spot right there. Definitely a fan of the face shield when I'm doing the ceramic. Those chips build up and then it turns red hot and throws it right in your face. So now I need to turn this down. I think they call it a spigot. I don't know, whatever the terminology is. I'm no good with terminology if you haven't noticed. But basically I need this cylinder to be 631 thousandths, because that's the size hole that my 5/8 drill bit drills. So then with the new rod, I'll drill that hole in the rod, and the two will be perfectly centered on each other. So my tool needs a little more reach. I know you guys know what I'm talking about. $631. So that is ready to part off. We have one eye with a spigot. Is that called a spigot? I think it is. Now we need a rod. Copper soft jaws. Alright, last time I did this, I couldn't get much of a chamfer on there because I was having trouble cutting that hard stuff. So while I've got the ceramic in there, I'm going to go ahead and chamfer using the compound to generate the angle. Didn't love that angle, so I made it a little steeper. That'll do it. Now I really didn't want this to be a boring video, but some things are unavoidable. I don't have the right drill bit. That's supposed to be 15/16. I've got an inch and I've got 7/8. So I'm going to have to bore. And this is just a tap drill size. It doesn't have to be exactly 38, but when I'm machining, I end up having fun trying to nail it. It's good practice. And I got 922. Let's just dial in 10, which should be 32. Just over 32. So I need 8, which would be 6. I'll do 5. Actually did kind of a light 5 there because I'm a wimp. Wow, that's it. That's 938. 25, 35, 6, 7, 8. Let me put a little chamfer on that and we will be ready for my next new tool. So the last time I did this job, I did single point threading there, mainly because I didn't want to have to wait for a tap to come, but I've known I was going to be doing these for a while now. So I went ahead and ordered a tap, because I've got 3 of them to do, maybe another in the future. I think this was 40 bucks, high-speed steel tap. I think it'll be worth it. So this style of tap is a hand tap. It's meant to be done by hand as I'm doing here. I'm really tempted to try power tapping it, but I didn't want to screw anything up, so I decided to hand tap this one, and while much faster than single point threading it, it was still a lot of work. The further I got into this, the more I was thinking, the next one I'll try power tapping. I do use Tap Magic. It definitely does better than just regular cutting oil for tapping. Alright, that should be it. Alright, right, so that's the end we just threaded. So that is ready for the piston. This end is going to have the eye. So I need to cut it off there and prep it for weld. And that would be a lot easier if I didn't have that hardened layer. But we'll go to our ceramic again. Still hard. Thought I had it, apparently not. Look how much happier that is. Darn it. I know better than that. Broke off the cutter. So I made the spigot and the hole the same size, so this should be a very snug fit, but it's not an interference fit, so I should be able to push it in right there. So let me get the welding blanket. Okay, so now I'm just going to do a few tack welds, and I'm not going to do the rest of the welding on my lathe like I did before. I didn't hurt it before, but I did burn through my welding blanket, and I think there's a better way to do it. That'll hold it until we get ready to really do some welding. So this next part brings us to the sponsor of this video, Vevor. You know, I was looking for one of those motorized welding setups where you can weld a horizontal round and it will spin it for you while you're welding. You've seen it on Cutting Edge Engineering and sure other places. Well, those things are ridiculously expensive. I just don't do this often enough to justify spending $2,000 for something like that. So I was looking around for an answer to this, and Vevor had just the solution. So these are roller stands, and man, these things are really, really heavy duty. Check that out. It automatically locks to height, and then you can adjust it further with this to fine tune it. Let it back down. When you know you've got it where you want it, go ahead and lock it. And these things are built strong. Wouldn't surprise me one bit if you couldn't use these as jack stands under a car. I'm not saying you should, but that's how they feel. These things are like heavy duty. A pair of these was surprisingly affordable, and they've got the rollers on them that I need. Now, with a little bit of ingenuity, I could probably come up with a way to motorize this, but in my experience, it's really not necessary. If you can turn it, your weld is going to be much better, and I think this is going to make this process way easier and give me a better quality weld at the end. So this is a piece of aluminum to protect the chrome, and of course the aluminum is much softer than the chrome, so it's not going to hurt it. And I'm putting a couple of these in the far end just to act as counterweights so that it will stay there and not want to fall over. Obviously, these things are for a lot more uses other than this, but if you have anything that you're doing round work and it's heavy, you know, big cylinders that you need to be able to hold horizontally, I would definitely recommend these stands. I'm really impressed with how heavy they're built. Quite honestly, when they sent them to me, I did not expect them to be this high quality. So, thanks, Vevor. If you guys are interested, I'll leave links in the description. Let's get this thing welded up. But before I do, I want to preheat.
Yep, that's gonna do it. Well, it isn't beautiful, but I think it's going to work. While that's cooling, I'm going to go ahead and start on the second one. Now, I have a couple ideas that are going to speed this process up, so I'm going to try those for the second one. And then on the third one, I'm going to time how long it takes me start to finish. Rather than using a ceramic insert right here for this hardened area, this is a junk rod. I don't need to worry about it. I'm just going to take this to the belt grinder, and I'm going to take that off of there. And hopefully that'll speed things up a little bit. Alright, I'm not sure that saved a lot of time, but it wasn't too bad. And I've just basically knocked it off so that everywhere I go with the file, it digs in, as opposed to this, where it's hard as a rock. Yep, that'll do it. Wow. Really? The center they have in here is not even close. How much run out there is on that. The rod is spinning true, but the eye is wobbling all over the place. That's like a 1/4 inch off. So I think what I'm going to do is I'm going to thin this down. I'll get it down to something that maybe I can bend it and get that back on center, and then go from there so that I can at least turn the spigot true with the eye. But this thing's going to throw me a curveball here. I've got a bit of a hard area there. Yeah, darn it. So I didn't want to use the ceramic insert here for two reasons. One, I don't want to spin this bent, unbalanced thing to 1400 RPM. The other is it's an interrupted cut and very likely the ceramic would break. So I'm using an old carbide insert here. And a file, but it ended up it was still hard. I generally try to avoid grinding on my lathe, but I've got everything covered with cardboard. Try to catch all the abrasive, keep it off of the ways. Alright, I think I've got it now. Let's see if we can turn this thing. I've got to rotate my button insert because that hard stuff tore it up. Trying to bend that, it's just not going to happen in the lathe. I could go put it on the press, I guess.
Or I could get that smoking hot, get it up to red hot, then I could bend it, just forge it down, and then turn it true. That might be the better thing to do. I don't know, let me think on this. I'm still at like an inch, so I'm going to turn that down to, say, another 100 thousandths, and then I'm going to heat it up, and we're going to try to straighten it out a little bit. I've got it oriented so it needs to go straight down. Starting to glow. I think it's moving a little bit. Yep, she's moving. That looks good. So you can see the center that's there is staying centered pretty well on that drill bit now. Once that cools off, I can recut that center and actually support the eye and then turn my spigot, and I should be good. There, I let this thing cool down slowly, and you better let it cool down slowly or it'll get hard again. And it did not. I'm going to recut the center. It'll be pretty close. It'll be good enough. It'll probably wobble a little bit, but let's get that cut. There, that'll do it. Now I am supported. And this is turning true, but this will not be. The good news is when I look down the weld that's still existing from previously, that is turning true, so that's perfect. So I just need to turn a good spigot there. Alright, I got my tap follower there. Let's move that in. Now this is Tap Magic. I'm going to start out by hand, just because. Man, it gets hard quick. Alright, so here's the plan. I've got the lathe on low speed. The wrench is pushing down underneath the way, so that's not going to hurt anything. And I should just be able to turn it on. I'm going to step back here, just in case. Here we go. Let's back off. Seemed to work fine. Wow, I'm becoming a fan of power tapping. Was a lot of work to do by hand. And maybe I'm being too cautious. I mean, this is not a tap intended for power tapping, but it's a huge tap. The chances of it breaking, I think, are really very slim. Now I do not want to hit the bottom of the hole with that wrench on there, I can tell you that. I doubt I'm strong enough to do it with pliers. There's the bottom of the hole right there. Alright, well that was a heck of a lot easier. Alright, so that is my final length. So I need to clear a little bit this way so that I can part it off there. And then I need to clear a little bit that way so that I have an area to weld. We got the ceramic, and we're going to 1400 RPM, fast as this lathe will go. Which quite honestly is a little disappointing. I've never come up across this lathe not spinning fast enough. It's actually a little bit under speed for this diameter, and anything smaller diameter than this would definitely be under speed for using ceramic. Something to think about. Probably see on that last run I didn't get a bunch of sparks, I just got a long stringy chip there, so should be through it. Oh yeah. This time I'm using another roller stand to help stabilize my welding hand. And it definitely went better. I mean, it still isn't pretty, but that's a good solid weld there, and I'm happy with that. That's not going anywhere. So for the third cylinder, I now kind of know what I'm doing. I'm going to time myself and see how long it takes me from this point. How long does it take me to have a new rod on there? Now, I'm not going to rush like crazy because I'll end up scrapping the part, but it's 8:27. Let's get to work. Yeah, that center's not true either, but I think it's better than the other one was. Let me see if I can recut that like it is. I'm going to use the tool post to help stabilize that while it's finding a new center. Nope. So I'm just going to bore a 30-degree angle, which should be concentric, will be concentric, and give me a new center that my live center can ride in. Yeah, that looks happy. I've got a new edge on my ceramic insert, and I'm going to use that to take off the hardened area. The belt grinder I don't think was the best move. Yeah, it's soft there, hard there. Yeah, that was definitely faster than the belt grinder. A little more expensive because those ceramic inserts are not cheap. Well, 631.5. I'll take it. It's 9:04, so about half an hour. Let's go. That's perfect. It's a little bit snug. That's what I want. 10:07. Okay, the rod is on there. It's at 10:30. What time did I start? It was like 8:30. So 2 hours to replace a rod. That's actually not bad. Well, you know what they say, a lathe and paint makes me the welder I ain't. Or something like that. It was the first one I did. Alright, I'm ready to start getting these rebuilt. So this is the one that had the worn out wear band. They did not have the right width wear band, but you can stack them. You can put two to make the right width. You know, it's just a wear band. It seems like putting the little one on the inside makes more sense. Now the gland. So this thing's, there's not a whole lot to it. I'm hoping I can just shove it in there. Alright, so this one's pretty tough. I mean, I can bend it obviously, but just shoving it down in there's a lot harder than doing this. People always ask, this is just a cheap Amazon special. I've got them in my Amazon store. It's worked great. I've used this on quite a few cylinders now. And every time I'm glad I bought them. I'm going to go ahead and get a little grease down in there. Now the outer gland seals, we're going to put these together correctly as opposed to how they were on, I think it was this cylinder. So the backup ring goes away from the pressure. Just make sure it's not all twisted up. Gland is done. That's ready to go back on. So I just want to get this piston seal on here. So that's the preload ring that pushes the seal out against the wall. And this guy is probably going to need to be heated up in oil, I think. Yeah, that thing is, yeah. All right, piston is done. Turn it up to 11. Oh man, couldn't even move it after the impact wrench tightened it. That impact wrench is impressive. Barrel is nice and clean. Gonna lube up my entry. That's always a good idea. I've got the caps loose so they can let air go through. One rebuilt cylinder. Still kind of ugly though. So I'm going to get the rest of these rebuilt and put back together. Unless there's something interesting, it's just going to be a quick breeze through. So this is the one that I'm rebuilding. It was leaking, I believe, because of the rod being scratched, and the gland seal, where it was leaking, looks perfect. So I'm leaving it in there. Hope I won't come to regret that, but I mean... Click! That's a new can of Krylon paint. Not impressed. think that'll do a little better. Those look a little too pretty for this machine.
All right, when I was tightening this this keeper, let me see if I can give you a view here through this little crack. That bolt right there holds this keeper, which then holds the pin in place. It never got tight, and I think it's about to break off. I could leave it, but it's a gamble, because if that pin comes out, one, I'm going to lose the pin, but that's not a big deal. This would come loose, and then when the cylinder retracts, it's going to pull the hydraulic lines and break the lines. So that would be a very expensive thing just because of that bolt. So let me try taking it out and see if it is breaking off like I suspect. Maybe not. It felt so squishy though. I think I'm going to get this bolt out of here and see if I have a newer one. And there's the bolt. You can see the threads are not the best, but it's not broken. Let me see if I have another one. All right, shiny new bolt. Click.
All right, much better. Yeah, that would have really aggravated me if I had left it the way it was. Oh shoot, I never thought of that. I had this cap closed. I was like, wow, I have so much control. Yeah, I think maybe just cracking that so the air can't go out too quick will keep it from launching. Not for when you're disassembling, but for doing this. Huh, learned a new trick. Stick my finger in there and get it lined up. It's a good way to lose a finger. I'm going to go turn the vacuum on and we'll hook up all the hydraulic lines. This had me worried for a second because the blade was flopping around really funny, but then I realized it's just because there's still air in those cylinders, so they're not able to support the blade like they're supposed to. There, that's more like it. There's no need to bleed air on systems like this. This is not a brake system. There's such a high flow going into and out of that cylinder that any air gets mixed with the oil and just returns to the tank. I'm just cycling everything several times to make sure I get all the air out. This thing had been sitting in this spot way too long. So it turns out there's not a lot of dozer work that I need to do right this minute. I mean, there's a bunch of stuff coming up, but right now I just want to do something with this just to verify the cylinders are good. I'm pretty confident they will be, but let's make sure. And so there's a spot down here in this bottom where there's a hole that I can grade it out and clean it up a little bit. Well, clean that up a little bit. It's just a mud hole right there. I was just sinking in. I can't compact it. I just make another hole. So that's going to have to dry out. I did take some off of this so that at least it'll drain now. It's a down slope. Now, that's a future project that I want to take on, but that's a big job. It's going to need a lot of fill, and I don't really have time to do it right now. But this entire strip here is an old road, and the road's sunk. So it kind of divides two fields and it just grows up with junk. It's hard to mow. It's impossible to mow. That's why it looks like this. So I would like to go through, clear the whole thing. I'm going to need to strip topsoil back quite a bit, regrade it all, bring in fill if I need to, and then bring it back, put the topsoil back, and make it good field. Right now I'm just playing around, and we'll tackle that later. I think I did enough here to show that my repair is successful. That cylinder is perfectly dry. The one that I replaced the rod before is perfectly dry. So both of those cylinders are repacked with new rods since I bought this thing. And both of these as well. And they look great. More importantly, the one that was leaking a little bit before is no longer. So that's awesome. And I definitely used it long enough that I would see it. So the only other cylinder on this thing that could need attention, boy, I'm jinxing myself right now, is that one there. But you know, that's not a big deal. If that ever needs it, I'll do it. So yeah, the old girl's looking a little better and no longer leaking. Real happy with that. So doing 3 cylinders and 3 rods was a pretty big job. If you're wondering how long did that take me, it's hard for me to say because I'm filming, I'm editing, doing it all at once. I would say it took me around 4 days, I think, to do it, including running the cameras. How much did it cost? Well, it was $80 a rod. I already had one, but even if we count that, that's $240 for the rods. And then the seals, I think, came out to like $150, something like that. So just shy of $400. And yeah, pretty much all my cylinders are good to go. Real happy with that. Hope you guys learned something. I certainly did. I always do when I'm working on equipment. Thanks for watching. We'll see you on the next one.